Using the James Webb Space Telescope, JWST, astronomers have ended a nearly decade-long game of celestial hide-and-seek after they discovered a neutron star in the wreckage of a stellar explosion. Supernova 1987A represents the remains of an exploded star that once had a mass around 8 to 10 times that of the Sun. It is located around 170,000 light-years away in the Large Magellanic Cloud, a dwarf galaxy neighbor of the Milky Way. Supernova 1987A was first spotted by astronomers 37 years ago in 1987, hence the numerical aspect of its name. As it exploded, Supernova 1987A first showered Earth with ghostly particles called neutrinos, and then became visible in bright light. This made it the nearest and brightest supernova seen in the night sky over Earth for around 400 years. Supernova explosions such as this are responsible for seeding the cosmos with elements like carbon, oxygen, silicon and iron. These elements ultimately become the building blocks of the next generation of stars and planets, and can even form molecules that may one day become integral to life as we know it. These explosions also birth compact stellar remnants, either in the form of neutron stars or black holes. For 37 years, astronomers haven't known which of these may lurk at the heart of Supernova 1987A. Scientists have been fairly sure that the object in Supernova 1987A is a neutron star, but they couldn't rule out the possibility that this newly deceased star, at least as we see it 170,000 or so years ago, hadn't gathered the mass to transform itself into a black hole. One other possibility was that the infalling matter could have been accreted onto the neutron star and caused it to collapse into a black hole. So, a black hole was a possible alternative scenario, Barlow said. The spectrum that infalling material produces is not the right type of spectrum to explain the emission that we see. However, the newly identified neutron star had avoided detection for 37 years due to the fact that, as a newborn, it was still surrounded by a thick shroud of gas and dust launched during the supernova blast that signaled the death throes of its progenitor star. Detection has been hindered by the fact that the supernova condensed about half a solar mass of dust in the ensuing years after the explosion, Barlow said. This dust acted as a screen obscuring radiation from the center of Supernova 1987A.